Now the topic is assignment problem. Assignment problem is a single or a special type of transportation problem. In transportation problem, we need to transport various amounts of quantities to various destinations. But in assignment problem, we are to assign a job to a particular person. The main purpose is optimize the result. It means either maximize the profit or minimize the total cost. It is just a particular case of assignment problem. Now, the mathematical formulation of an assignment problem. Suppose we have n jobs, n jobs. Suppose we have n jobs, and these n jobs are to be performed by n persons. Means each person is assigned a single job and each job is assigned to a single person. There is a 1-1 correspondence, we can say. And suppose we have xij is equal to 1 if ith job is assigned to ith person, jth person, or if ith operation is assigned to jth operator and xij is equal to 0 in all other cases. Otherwise, then the assignment problem is the following LPP. Maximize z is equal to summation I is equal to 1 to n, summation j is equal to 1 to n xij, and subject to the constraints or subject to the conditions, subject to the constraints, summation xij is equal to 1 as varying from 1 to n for j, and summation j is equal to 1 to n xij is equal to 1 for I. Also, xij is equal to 0 or 1. We have various methods to solve a particular or to solve any assignment problem. One such method is method to solve assignment problem. One such method is Hungarian method. Hungarian assignment method. Hungarian assignment method. Now we will look into an example and solve this problem. Example. In this example, there are 4 tasks or 4 jobs, you can say A, B, C, and D, and these 4 jobs are to be performed by 4 persons E, F, G, and H. The question says that a departmental head has 4 subordinates E, F, G, and H, and 4 tasks A, B, C, D. 4 tasks A, B, C, D to be performed by E, F, G, H. Obviously, the persons E, F, G, H vary in their efficiency of work. Simultaneously, the task A, B, C, and D vary in their difficulty level. So, as we understood about the difficulty and the performance of each subordinate, he made a following table where the man hour is given. Man hour is given, it means task A is to be performs. If task A performs E, then he takes 18 hours. For the same job, F takes 26 hours, G 17, H 11. Similarly, for B 13, 28, 14, 26. For C 38, 19, 18, 15, and for D the times are 19, 26, 24, and 10. The question says that how should the task be allocated one to a man so as to minimize the total man hours. Here we need to minimize the total man hours for performing a particular task. Okay, its solution is, as Hungarian method says that number of columns should be equal to number of rows. Here we say 1, 2, 3, 4, 4 rows and 1, 2, 3, 4, 4 columns. So the problem is balanced. In step 1, we need to make zeros in each rows and in each columns. It can be done by subtracting the smallest row of each smallest element of each row from all other elements, and the same will be done for the columns. So the next I am just making here the smallest number is 11. So when you um, subtract this 11 from all other numbers, the first row will be changed to, suppose this is our initial table is our T0, this is our table 1. Here it is 0, 11 minus 11. This is 17 minus 11 means 6. 6. 17 minus 11 is 6, and 26 minus 11 is 15, and 18 minus 11 is 7. Similarly, the smallest number here is 13. So 13 minus 13 is 0. 28 minus 13 is 15. 14 minus 13 is 1. 26 minus 13 is 13. Here the smallest number is 15. So 15 minus 15 0. 18 minus 15 3. 19 minus 15 4. And 38 minus 15, 8 minus 5 3, 3 minus 1 2, it is 23. The smallest number in the fourth row is 10, so 10 minus 10 0. 24 minus 10 14. 26 minus 10 16. 19 minus 10 is your 9. Now we see that each row has single zero, each row has one single 1 0. So now our purpose is to make zeros and assigned one. Now we will start from the first row. From the first row, this is the first 0, so we will assign this as square bracket, and all other zeros will be, no, one thing remains. We have all zeros all rows having one zero, but not all the columns. So this procedure is repeated for the columns also. For the first column, this is the smallest number. If we subtract this from other, the same table we will get. Now we will have table 2. From the second column, the smallest number is 4. Subtract this number 4 from other elements, so it will be 0. This is your 12. This is your 11. This is again your 11. In the third column, the smallest number is 1. So it is 0, 1 minus 1, 3 minus 1, 2, 6 minus 1, 5, and 14 minus 1 is 13. Now we will have 0 in each column and in each row. So now we will make assignment. This is the first row, assign 0 here, and as per Hungarian method says, all the rows in the assigned 0, all the other zeros will be crossed out. So we will cross this one and this one. Now go on to second row. This we will assign. Go on to third row. This is an assigned one. And now go. We will go on the first, second, third, and this is also we will cross this zero also. Now we can see that we have only 3 assigned zeros, but the problem is of 4 rows and 4 columns. So we must have 4 assigned zeros. Now we will need to make tick